This is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 7-3 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to apply the square of a binomial. Alright, so here we have it. We have a blanket? I don't know what this is. So it says a graphic designer is developing images for an icon. Alright, so this is some kind of desktop icon, I guess. The square pixelated image is placed inside of a border that is 2 pixels wide on all sides. If the area of the border of the image is 176 square pixels, what is the area of the image? Alright. I'll be honest, when I first saw this problem, I thought they were asking the other way around. I thought they would give us the area of the box and ask for the outside. But they're giving us the outside and asking for the inside. That's fine. So let's go ahead and let's develop some kind of battle plan. Alright? So to find the area of this image, right, I would take the total area, the entire box, and I would subtract the area going around, right? I would subtract the area of the border. And that would leave me with the area of the image. Alright, so that's going to be my goal here. Now, they've already told us the area of the border, right? They already told us the area of the border is 176. But now, let's look at the total area. So, notice they are calling x the distance here. Now, I could call the area of the image x squared, really, if I wanted to. And so they're getting this side here, x plus 4, by saying that this distance is 2 units to the side. So my area total is x plus 4 squared. So there we have it. Okay, there's my little formula. So I have my x plus 4 squared for the area total. I have the area of the border is 176 pixels. Someone must have gone and counted them. And the area of the image is x squared. Alright, so now I'm actually just going to go through and use that that formula that allows me to distribute this easily. So remember, if I have a plus b squared, it'll distribute like this. It'll turn into a squared plus 2ab plus b squared. And so that's what I'm doing here on this. Alright? So my a term is x, so I have x squared plus 2 times a times x. So a times x, or sorry, a times b. Right? 2ab. Here we go. So x times 4 is 4x. Times that by 2, I get 8x. And then plus b squared, so plus 16. Alright, so now I'm just going through trying to solve for x, really. So most people, right, they'll see right here they could collect these like terms. So I'm going to go ahead and do that. So I have x squared plus 8x minus 160 equals x squared. And now with problems like this, you usually want to get all our x's onto one side. So I'm going to subtract x squared from each side to move that over. But what's nice is I only have an x squared on this side. So what ends up happening is the x squared gets eliminated. Then I want to add 160 to each side. So I get that 8x equals 160. Ooh, I might run out of space on this, y'all. And I divide by 8. Yeah, I sure did run out of room. So there I'm dividing by 8. And I get that x equals 20. And then you might be saying, well, if x is the length and width of the image, 20 what? 20 pixels. That's their unit of measurement. All right, so now they're doing this again. However, they finally switched it up a little bit. They're saying that the border is 4 pixels wide instead of 2. So what that means is that this is x plus 8 on the outside. So my area total is x plus 8 squared. All right. Minus the area of the border, which they're telling us is 704, is equal to x squared is the side of the image itself. All right, so now let's go ahead and let's solve this. So first I'm going to actually kind of expand this here, right? So I'm just following the pattern. So I have a squared, so x squared, plus 2ab, so plus 2 times x is 2x, times 8 is 16x, plus b squared, so plus 64. And then don't forget the rest of the equation still exists, y'all. Now, remember, on the last problem, our x squareds canceled out. So since I don't really have enough room, I'm going to go ahead and cancel those out right away as well. And again, remember, that's just through subtraction, okay? So I have 16x, and then I'm going to combine these minus, ooh, I don't actually know what that is off the top of my head. So if I plug it into a calculator, I get negative 640. And then now I need to isolate x. I need to get the x alone. So I'm going to add 640 to each side. So I get 16x equals 640. And I'm going to divide by 16, but I don't have enough room on my page to show you I'm dividing by 16. But when you divide by 16, you get that x is equal to 40 pixels. Wow. Alrighty, so there we have it, guys. That was how to apply the square of a binomial. Until next time.